Welcome to Circuit Valley. I'm Gaurav. Today I'm going to show you my solution, how I constructed myself an absolutely noise-free lighting solution for my test bench. As you know, normal LED lights and CFL lights, when they are driven, they generate quite a bit electrical noise because of the switching nature of their power supply unit. So you see on my bench, this video is going to be about my workbench. So you see this little aluminium part which is running along my bench. This is my LED light and it is mounted to aluminium extrusion using 3D printed parts, and it runs all the way through my test bench and it illuminates my whole of the test bench and completely noise free and it runs such a way that it never glitter into my eyes and only illuminates my workpiece. It only illuminates the thing which are under it. It never fall into my eyes because of the height and everything else. If you want, I can show you going down that it is pretty well illuminated and pretty well lit. And how is it controlled? It is controlled by this little unit here. And if you have keen eyes, you can see the fan which is getting used in that unit is exactly same as Intel fan. Maybe I'll make some place so that you can see it. So I made some room now. You can see it. This is a 3D printed enclosure again, mounted on the side of my bench, and there's an Intel fan which is running constantly in there. There are a few coincidences which helped me a lot fitting it in a nice enclosure. Power supply has this nice linear potentiometer, so it can adjust the brightness to pretty bright and to very low, and you can even turn it off if you want to, but I do not like it to be turned off this way because every other electronics part is on. So there is a dedicated power switch, and when this switch is on, then unit turns on. If this switch is off, it turns off. It outputs, because the fan is there, so it outputs a little bit warmer air through these holes. This is how it looks mounted, and it works pretty well. It does not generate any noise because the power supply which is driven from is a linear power supply. I'll show you the solution. How can you implement this thing for maybe €5 or something like that if you are really courageous. So let's take this unit off the thing and we will show you this whole solution. I have taken it off my bench and now it's sitting on my table, and these two, they are just glued in with the super glue. These two parts are standard 30-30 aluminium extrusion fittings, and they are also 3D printed from same PLA, and it slides in like this onto the rail, and these things get bounded or tied onto the vertical aluminum profile. So I'll show you now. I'll open it up and I'll show you what is in there. I'm pretty sure you have seen it before, but you never really wondered that this can be used for there as well. They are pretty long screws actually, because they go almost all the way through to reach the other end where the nuts are. This is one little flaw of this design which I made. So it's off. This little stud is supposed to push a little bit on the PCB so that it stays in place and doesn't move, because I'll show you this PCB. If you recognize and you have keen eyes, this PCB is nothing special. This PCB is the Chinese 30 volt 3 ampere power supply unit, which you can buy for maybe €6 as a kit. I took that kit, replaced the op amp and transistor with my own because I was not sure if they have a genuine transistor or a fake transistor. I put up this linear potentiometer, put up a heatsink, and put up this on-off switch, and this voltage adjustment is set to maximum. The current adjustment is set to from 0 to 3 ampere maximum, which will definitely control a current driven device LED and set its brightness. So it's as easy as that. It's a linear power supply, inherently noise free. Where I got lucky, so if you see closely on every side, you see there are plastic studs kind of thing protruding. Actually I got lucky in this case, and I am using a standard Intel CPU heatsink, which you can buy maybe off eBay for €10 or something like that. I'm using that for the cooling fan, for the cooling of the transistor, and these the screw holes in the PCB, they exactly matches this pin pitch of this heatsink studs. So they are exactly same dimension wise, and you can just directly plug in this PCB into a standard Intel heatsink and it will just fit out of the box. So the switching transistor is directly mounted onto this heatsink which is sitting behind there, and it's cooling the switching transistor. And there is one more transistor down here, and there's this current sensing resistor. So this is this current sensing resistor also have a heatsink because it also gets a little bit warm. And this is the connector from Vago. This is where the LED connects. A little bit unplanned, but it was a 2-day project, and I have to supposed to get it done somehow. Even the switch is coming into the way of the PCB, it does not let it out. This is the fan, fan connector is directly driven. This is the switch which turns off and on, and you see it's come in the way of the PCB. PCB cannot take it be out without the switch and without this wires to be removed from there. It was a 2-day project, quite hastily done, and it is powered. If you see, I had one laptop power supply lying with me, one Sony laptop power supply. I took the connector from the laptop itself because it was dead, and I used a standard Sony power supply which was around 19 volts, and I used that power supply to power this whole circuit. And why this Traco power thing is there, I'll explain to you in a minute when I show you my custom LED strip which I designed for this thing. Why did I design LED strip? Because I had many Philips Luxion LEDs lying with me, and I wanted to make my own thing rather than buying something. So I made small aluminum PCBs and made a LED strip after them and installed them in there. So let's take it out and we'll see how does it look from behind, or how does it look from the front actually. So I've taken off the LED wires. Maybe we can lift this thing off. No, it cannot be lifted off unless this thing is removed. So this is removed. Let's remove this pot place as well. What is preventing it from coming out? Absolutely nothing. No, there is something which is preventing it from coming out. Yeah. So this is how it looks from the back side, and I'll show you the place where I have transistor installed. If you see it, the transistor is installed down there. Okay, so it's directly screwed. I have taken drilled a M3 hole and directly screwed in there, and this PCB directly fits on this heatsink. This nothing is from Intel LGA 1157, I think, standard heatsink. And this is the connector for the fan itself. Although it's a 12-volt fan, it's powered from a 5-volt supply. And why it's powered from 5-volt supply and where I sourced it from, I'll tell you in a minute. This has to do with the Traco and has to do with my LED strip as well. So it's as easy as that. These op-amps are my own, and PCB is from China. Resistor, everything else is also from China. And this primary resistor is also from China. It's nothing special. It does the job really well. I've been using this solution for ages now, and it works absolutely perfectly. So looking at the LEDs itself, this is how they are mounted, and they are mounted all the way through using heatsink compound, and heatsink compound is a glue, not the grey one, but there is a dedicated heatsink glue available. This is how individual PCBs look. They are standard aluminum backed PCB meant primarily for LED. They're made by JLC PCB. So you see it allows six Philips Luxion LEDs, and these LEDs are mounted in such a way that you can connect 3 in series and total 6 in parallel. So they will be in series and they will be in series, and you can connect these 3 and these 3 in parallel, or you can connect all of them in series. So you may need to mount some 0 ohm resistor in there, and this is how they are configured. And that's where I made mistake, because you must understand that LED needs some that long LED strip. They need some dropper resistor, because this was my first time dealing with LEDs. these individual PCBs, they are mounted like this, one another up to the 2 meter length. So even a slight voltage difference from here to the other end, you will see a massive difference between brightness if you do not have a dropper resistor. So what I did as a solution, instead of mounting a dropper resistor, I placed very thick wires, and this is very good copper wire mounted on alongside of the edge of this what do you call it, of this PCB strip, and they deliver close enough voltage that you do not see or have a measurable difference in the voltage. It works really well, but if I design this project one more time, I will have dropper resistor. I'll have a dropper resistor. And the second mistake which I made on this strip is, you see there are 6 LEDs. So when you have 6 LEDs, you need like a 24 volt power supply or something like that, because there is a drop in the regulation and everywhere else, so you need 25-26 volts, something like that. And if you remember, no laptop supply or no power supply which you can find very easily and cheaply on market for maybe 10 euros, 15 euros, or maybe have lying around. Generally they are laptop power supply 19 volt, 20 volts or something like that. So you need 24 volt for these guys, but I don't have 24 volts. So what did I do to get 24 volt? Getting back to my mistake, I took 19 volt from the power input from the laptop. I put this DC-DC converter, isolated DC-DC converter, which was also I had lying around. I connected this, supplied 19 volt to it, and then took different references so that I get 19 plus 5 around 24 volts. And the same 5 volt supply is used to power the fan as well, because I don't have any 12 volts or 6 volt or 9 volts, so that I can have it running with that power supply. So this power supply connected in series with the input power supply give me 24 volts at 2 amperes, and with that you get maximum like 48 watts, but that's good enough for me. And same 5 volt is used to power this fan as well, because otherwise I needed to mount one more regulator. There is no what do you call it, way. I did not have maybe parts at the time or something like that, but it works really well. I have it since like 2-3 years now, and never had issue. The fan run constantly, very slow, does produce a little bit noise, because these fans, when they run a little bit faster, they would produce lesser noise. It is too slow for my liking. Maybe I'll find a solution someday, but not today. And so you can in theory just shove something into it and it never heats up. It's a little bit warmer. When you do not let the fan run for some time, then it warms a bit, and in plastic, the PLA, it never had a problem. And if you want to look at the pot, this is the linear pot I have installed there, and this linear pot also served well, did not have any problem with it. So this is how you make really low noise linear power supply LED driver for your bench. The mounting hardware, I'm using this 3030 aluminum cap, which is also 3D printed, and this J shape, it is designed around the LED, this aluminum profile as well, and they are glued together, and it just slides in, and this mounts this thing onto the aluminum profile and doesn't bother. It's mounted to multiple places exactly like this, and no issue. So, and you will see sometime I have these plastic protection things, and they are primarily there to protect my cables against the warmth of the LED, because there is a possibility this, if you're driving it on the full power, it gets a little bit warm. It never gets hot, because I'm not driving them too much, and it's 45 watts spread over like 2 meters or something like that. So they do not get hot, they get a little bit elevated temperature than normal. So I wanted to protect them. I do not care about the LED itself. It can get warm, get damaged as it wish, but my cables are more important, so they get this little plastic protection. So I hope you enjoyed this video, and this LED project of mine you found useful. You can visit my website www.circuitvalley.com.